The importance of high-performance computing can't be understated. But interestingly enough, it's the modeling and simulation which really gives the answers to the questions that need to be asked. High-performance computing is effectively the infrastructure that allows that to happen. We would not have modeling and simulation if we didn't have high-performance computing. So there are a number of types of high-performance computing. And the traditional type that we have all grown up with has been to support modeling and simulation. You know, the climate modeling, the life sciences, the manufacturing simulations. But what seems to be happening is that the processing of very, very large amounts of data is becoming as important as traditional modeling and simulation. So you'll see the large amounts of data coming up in life sciences, particularly in places like personal genomics, cancer genomics. You'll also see high-performance computing supporting the massaging of the very large amounts of data out there that come from financial analysts, demographics, social media sites to be able to track trends in our society. So computational sciences is very important to innovation. It allows us to explore things that cannot be explored by experiment. So in other words, when we simulate things in the computer, we can actually see what physical processes do. We can see what manufacturing processes do. We can see what happens in terms of climate modeling, life sciences. These are things we can't experiment upon, and we can actually measure things in the simulation that could never be seen in the laboratory. The additional advantage for innovation is that we can do those things and replace the smaller costs of computation with the larger costs of building prototypes in the laboratory. So it's an economic savings.